I've been waiting 9 years for this day. Every time I've had a bad day, this has been the project that I've been thinking of. For you see, this thing has been clogging up my bucket list for all this time. But now, it's time to blow off the dust and really get into it. Let's just start by making the thing take off. So I'm going to get the autopilot started. Cool, and we just wait a few moments here, so it's just going to sort itself out. Basically the dependencies, it hasn't received the data yet, but probably by now it has got all of that now. So we can see that there's a whole lot of data there. This is stuff that's coming from the flight simulator.
And what are those data for?
So
I see elevation and...
Yeah, so it's the state the plane is in, both in terms of how the plane is physically moving. It's all the various controls, like what the landing gear is doing, what the engines are doing, all of this type of stuff. What I'm going to do now is I'm going to type in fly to. The first parameter defaults to the default instance, so I can just leave that blank.
Out of curiosity, what does it mean, instance?
I'm working towards being able to run multiple
planes?
Multiple planes from one autopilot.
Okay.
But that's something a bit further down the track. Cool. So if I hit this, and then we'll see that the thing, there we go, is starting to move. Now, in a moment, you're going to notice a problem. And that is, there we go, notice it wiggled a little bit.
Okay.
And it'll probably do it a little bit worse sometime soon. What's happening is...
It's going to sliding a little bit right, but it looks...
There we go, here we go. So now it's going off.
Correct.
No, what happens is there was a bug in my autopilot that became apparent a few versions ago in flight gear. And I haven't dived in to debug it, but what I think is happening is I am making a request to the autopilot, give me this information about where I am. Then what happens is it sends that request off, and then it asynchronously handles the data when it comes back. Now what I think is happening is that enough data points have been added that the longitude and latitude are now on separate TCP packets. So
I see, but also it could be, if I may, it could be also that by the time it's processing it, you make a decision, the plane moved. So it's not exactly on that. Do you account for that as well?
I do. That is okay. That's built into every aspect of how it's working. But when you look at the data, I haven't actually got it at the moment. But when you look at the route data, you can see what looks like a straight line, and then there'll be one point which is off to the side, and that point where it's off to the side correlates with when the plane yanks off and tries to correct.
Why do you have that point of the side? Do you know?
Because I think like I say, I haven't dived into it, but what I think is happening is that it's receiving either the longitude or the latitude, and then in the next packet it receives the other one. And so instead of updating both of them together, which is what used to happen, they're now getting it updated independently, and so the point is, it's not far off, but it's enough off that it thinks, hey, it's off the runway, we need to correct this.
I see.
Yeah, so what it's doing now, you can see there are several sort of key moments that have happened here where it's sort of detected, yep, we've passed the point of no return, so okay, we have to continue. That means
the point of no return is when we are airborne?
That means that we're going too fast to be able to safely stop on the runway.
Oh, okay, fair enough.
So it means we have to take off no matter what. It's actually quite important to note that the V1, V2, VR, I haven't actually implemented those correctly. I've learnt a lot more about them since I first implemented these. That's a story for another time, but for right now, yeah, I know there's quite a few things I haven't implemented correctly, and at the moment I'm working towards achieving the goal. So maybe now is a good time to talk about the goal and what it is I'm trying to achieve.
Alright, so what are the goals? And maybe we can go even a step backwards. What is this about?
Yeah.
What is this whole project about?
I began writing a programming language called Actual in around about 2001. It has some ideas in it that were I don't know if I was the first to think of it, but it certainly wasn't. They weren't common ideas at the time. They're a bit more common now in a few sort of niche applications. But yeah, it was largely an experimentation playground for me. I made sort of the first proof of concept then, and I made a few iterations of it. I didn't really go very far with it. And then in 2011, 2012, somewhere around there, I started working on it again. And I got a design that I really liked. At that stage, I was really focusing on the robotics side, so I wanted to make the robotics side, like I wanted to really develop that. And so then writing an autopilot is kind of like the ultimate robot. It's like if you can't accurately control a plane, that's kind of a problem. So it's a really good test to make sure that all the different mechanisms are working. So the autopilot was really just, hey, let's actually push the robotics language forward and make sure that it's actually working properly. But life stuff happened, and I then didn't work on it for many years. The moment has long since passed for me to sort of present anything amazingly innovative with this. But it still sits on my bucket list as something that I've really wanted to do. Whenever I've had sort of a challenging moment in life and I'm thinking, well, I could be working on that, this is the thing which I think about that I could be working on. So I really want to achieve it for the sake of achieving it now, rather than it's not going to be a commercial success. There's other tools available that do things really well now.
Maybe maybe Boeing is just knocking your door.
Yeah.
They would like your product and would like to buy it.
There might be some concepts that I've got in here that might be interesting, but overall, mostly it's just a bucket list item for me at the moment.
And on that note, buying, is that project open source? And,
it is.
And which part? You mentioned the language, you have the simulator, but I guess we are talking two slightly different things.
Yeah, so the language is actual, that is open source. At the moment it doesn't have much outside interest, so I'm maintaining it at a works for me level. But then if there's outside interest, then we can start working on cleaning things up. When I began blowing the dust off this project a few weeks ago, I started looking at the code and going, coding standards have evolved a bit since then. And I was starting to think, this might actually be a bit too embarrassing. Should I actually show this? And then as I started working with it, I started just sort of getting these little glimpses of, oh yeah, I remember why I really loved working on this. So I'm putting it out there. Please understand that coding standards have changed, and there are significant portions of the autopilot in particular I've rewritten when I have been like the last 15 minutes, like I'm in the last 15 minutes before I get off my train. I won't get to look at it for another day. Or like a few years ago when I was trying to do a little bit before work each day, and it was just, I was trying to work on the fairly complex parts of it. So I was spending almost the entire time loading it into my head, and then I'd do about 5 minutes of actual work, and then it was time to put it down and start my paid job.
We all have to do that.
Yep, and so that means that there is a significant amount of code in the autopilot now that is, it's not even aged coding standards. It was low quality code to begin with.
I see.
So that's been one of the nice things about picking it up again now, is I'm right at the beginning of trying to get it into a working state. And I'm having to be a little bit pragmatic about, I see lots of things that I want to fix, and if I do that, I'm not going to achieve the goals in a reasonable time frame. So instead what I'm trying to do is, I'll see something which is likely to lead to a bug. For example, the way parameters are handled in functions. There's a lot of the autopilot code I wrote right at the beginning of the language. And so at that stage, you could think of the parameter handling being a lot like Bash. Mm-hmm. So in Bash, you have like the $1, $2, $3, $4. That doesn't make a lot of sense when you're trying to read the thing. And
for a bigger code base, you need a little bit better variable names.
So now I've got a function there which literally goes parameters, and you put in a list of names of the parameters that that particular thing takes in, and then all those parameters, all those variables get created for you, but also they get destroyed when the function ends. So the variables are scoped.
So there is no garbage collector then?
The garbage collection is handled by the parent language. So actual is written in a language itself, so the parent language is PHP. So this is before PHP became a really big sin that it is today. I've left the garbage collection to PHP to handle. However, I do some stuff proactively. Whenever scope changes, I've got the things that are in that scope being discarded proactively. Yeah, so coming back to the code quality thing, when I come into a function and I see that it's still using the old parameter handling method, I migrated over to using the new method, which is specifying the parameters that you want, because it handles the scope, it can handle default values, but it also, in the process of doing that conversion, I have to go through and understand the code to make sure that I'm making the correct changes in there. So it's a really good way of going and understanding what the code is doing. And I have actually solved a few bugs just by doing that. So that's been really nice.
And on that note, what is the plan with the project?
Yeah, so what I'm working towards right now is getting landing to working. Part of it, so there's a little bit of work, I'd say probably 15 minutes. Therefore probably 4 hours of work making the route planning work correctly. So that is a couple of things of making sure that if I'm already on a runway, then it plans the route correctly the same way it would as if I'm in the air and I tell it to fly somewhere. There's a bug in there that at the moment that I need to work through, and it's simply I just need to sit down and do it. It's not particularly difficult. And then there is some code that I developed, must be about 3 or 4 years ago now. I think I sent you a screenshot of the ice cream cone.
So the ice cream cone is quite a central concept to all of this. So let's quickly explain that now. The task is really simple. Let's imagine this is the runway. Our task is to take off from the runway, turn around and come back and land on the same physical runway but in the opposite direction. Logically that is termed a separate runway, but for the purpose of this exercise it's the same physical runway. So let's imagine what happens if we do that. We take off and we fly straight in this direction. And then we go, right, okay, we want to return to the runway. So what happens? We tell the plane to turn and it comes in and then it heads towards the runway. And it gets towards the runway, and then suddenly when it actually gets to the beginning of the runway, it's going in the wrong direction. Okay, so we need to make sure we have an approach straight to the runway. So we take off, okay, and then we turn around, and then we go and enter the approach. And we've come at a much steeper angle this time. So now we end up going around that approach, and we end up zigzagging around it. It gets very hard to actually capture that line. There are algorithms to do it, but we're making it very difficult for ourselves. So let's take that to the next logical step. Let's take off, and then immediately we're going to bank off in one direction. And then we get to a waypoint up here, and we want to get over to this line over here, so we go to a waypoint over here. So we go from here to this waypoint, back to the runway. That seems really good in theory, so let's play it out. So we take off, and we miss the line to begin with, but hey, we go and capture the line because it wasn't too far off. We go and get this waypoint, great. And then we begin our turn. And we're aiming, the whole time, we're aiming for this waypoint over here, and we have come from over here. So therefore, when we go across, we get to this waypoint, but now we're still completely in the wrong direction to gracefully capture this line. So what I've described so far is an empty ice cream cone. Because notice, we take off from the runway below here, and we go off, we follow one side of it, we get to one waypoint, we go across to the next waypoint, and then we're trying to capture this line going down. But it works a lot better with a little sugar. Look what happens when we put a ball of ice cream on top. Now, watch what happens if we play it out. This time, we start off at the runway, we take off, and we follow this line. And then when we get up the top here, instead of just trying to go straight over to this waypoint over here, we go around over the top and we follow the radius of the arc. And so then when we get to this waypoint, we're actually going in exactly the right direction to go straight down onto the runway. So at this point, we have left the runway, we have followed a line up, we have followed a line going round, and we've followed a line coming back down. And this gives us a nice clean approach. By doing this, we make things massively easier for ourselves because we have very clean lines to work with, we have very little noise, and there are fewer external factors which get in the way of being able to drive the plane in a straight line. It also means that we have a really consistent way of observing how much better or worse a given algorithm is at keeping the plane on the track that we want it to be on. So as I refine my methods further and further, this is going to give me a really good way of seeing whether I'm succeeding or not. Another thing to note is several things have to succeed for this to work. So once I achieve this, then I have confidence that I've got the foundations to achieve the things I want to achieve next. And you can see now, with a bit of testing and refinement, look how smooth this arc is. That's going to make things so much easier for the approach to the runway.
With these different control mechanisms, it sounds really simple when you say it in English, but when you actually go to program it, you've got how you handle, hey, let's get to the goal quickly, but then how do we control backing off at the right point and all that type of stuff. And like I say, the PID controller, that will make that easier, but it won't make it foolproof. There's still tuning to be done. Maybe this is a good moment for us to stop and then chat again once I've got all this stuff implemented. What do you think?
All right, sounds good. Thank you very much for the introduction.
Reality check time. I am nowhere near getting done everything that I wanted to do, but I am out of time. I'm going to give myself 2 more days, and I have 2 different paths that I can take. One is to do a whole heap of very small, spectacular looking things, and one is to do the thing that I've been obsessing about for the last 9 years. I think I'm going to go for the one which I've been obsessed about for the last 9 years. The catch is that if that doesn't work out, then I've got nothing to show. So it's a bit of a gamble, but if it works out, it's going to be worth it. So let's hop to it.
Your destination is on the right.
Hello, Kevin.
Hello, Csaba. Did you do your introduction thing in the end?
No.
That's absolutely fine. Do you want to introduce yourself now then?
Sure. I really don't know what do I say about myself. I'm Csaba, a software engineer. We know each other from a previous company where we worked together, and we know each other since 2014.
And have you got any projects or anything coming up that you would like me to link to?
Okay, that's a burning question. I have lots of projects coming up. I'm really into 3D printing, so I have projects related to that. One of the projects that I'm really currently working on is basically building up a cooling box for my NAS, which is not just getting it cooler, but is also very quiet. And it will be kind of automatically controlled by ESP32
That's
and
cool.
so on and so forth.
Cool. Tell you what, if you provide me links to those when they're ready, I will stick them in the description down below.
Thank you very much. I really appreciate it.
Are you ready? Drum roll.
I mean,
It's going to work. Editing Kev here. It's at this moment that I should probably explain that we had an unreal number of demo god difficulties during all of this, hence why the tone change at that cut. So let's come over here, we'll get rid of that, and we're going to start zooming out to have a look at what we're seeing here. So you can see here the planes going along the runway, and this is one of the triumphs of the project, is the fact that the plane actually does stay on the runway now, and it's holding it pretty well. So in a moment, about now, it's going to start rotating. Up it goes, the landing gear is going to go up, the flaps are going to come up, and then in just a moment, let's go inside the cockpit here. And just because this is quite a cool view. So what's going to happen in a sec, you see now over on the right hand side, this line here has gone green. So it's now navigating towards that, and you can see it's starting to bank towards to go and find that line. This was another triumph of the project. There were two challenges at this particular point. We'll get into the second one a bit further along the track, but the first one was just simply I needed to have some separation of the configuration for takeoff versus the configuration for general flying versus the configuration for landing and all this type of stuff. In doing that, having very different configuration with it reacting in different ways to how far away it is from the line and that type of stuff, to simply go hard change in configuration caused some erratic movements. To go and understand why it was doing those erratic movements is really cool. It was a nice sense of achievement to get that working.
Would you mind elaborating a little bit on what do you mean different configurations?
Yeah, okay, so if we go over to around here, here we go. So if we zoom in on this text here, this here is saying, right, we have passed a waypoint back here, and now we need to go and find the line. So it's using trailer cruise find line. So that's what tells it, hey, we could be anywhere in relation to the line, so let's go and get close to the line, then we'll figure out how to stabilize. And then we come over here, and you can see now it's got, well, hey, we're at the line, so now we actually need to steady ourselves on here. So we've got trailer cruise, steady line. Those are two very different configurations because the find line is very aggressive. You can see it's using quite strong turns there, whereas the steady line uses much more gentle turns. So you can see here that it is still not perfect, but it is getting a whole lot better. So this was another one of the triumphs of the project. These markers that I'm putting in here tell me information about the oscillations. So you can see here that if it's on the left-hand side, it is negative, and if it's on the right-hand side, it is positive. So P is positive, so we're on the right-hand side of the line, and it puts this marker at the furthest point, like when it's on the arch and it's returning back, it goes, that was my furthest point, and it tells you how many meters it is away from the line. Now you notice that we have two markers just before here. The reason for that is some error in the data that we're receiving. This was one of the big challenges of the project. Several years ago when I was originally working on this project, I got it very close to going down the runway basically straight. My algorithms still needed a lot of work. What I've done now is so much more advanced than what I had back then. Before, what I had was, well, hey, we're on the runway, and the database that I've downloaded says that the runway goes at this angle, and I'm currently facing at that angle, therefore we need to correct until we're facing at the same angle as the database says. Now I take that database, I create a waypoint at each end of the runway, and then I measure how far away I am from the line, and then I'm using the distance from the line to make sure that I'm staying in the right place rather than the heading.
And is there a better or other algorithm for this optimization to get on the line kind of smoothly and stay close to the line smoothly?
Yeah, so I've got several different algorithms in here. I'm actually going to bring over a window and show you. This here is the configuration I was talking about before. So here you can see this is the find line configuration. I also mentioned the steady line configuration. So this is where they're defined, and there's configuration here for saying, hey, if we are further than 120 meters, then we move over to this configuration, and that's set to NA at the moment. So find line is the most coarse configuration. But if we get closer than 400 meters, then hey, let's move over to the steady line configuration. So within each of these configurations, we've got various algorithms here, and this is saying how strong do I want each one of these algorithms. So this is a lot like how you would tune a PID controller. I've actually re-implemented most of the PID controller and a whole lot more in here. And they're not exactly one for one, so I've given them slightly different names so that it doesn't set expectations the wrong way. But there is a lot of similarity. For example, the overshoot is saying, hey, if we're going to overshoot the line, we need to start decelerating before we get to the line. This configuration here is specifying how much strength we want to give that particular algorithm, how much it contributes to the final result. What's really interesting is, remember, if we zoom back in, and we can see that here is the peak, and yet we got two peaks that were marked earlier on here. So remember before I was mentioning that several years ago I had the plane going pretty nicely down the runway. It wasn't completely working well, but for the most part it was working reasonably well. I didn't make this correlation at the time. It was only some time later that I realized. But at a particular version of flight gear, suddenly I wasn't staying on the runway anymore. It would be fine, and then suddenly it would lurch off in another direction. And I made various algorithms to try and deal with this, and everything that I was doing, I would look like it was working absolutely beautifully, and the next time I test it, it wouldn't work. The fact that it thinks it peaked there, and it thinks it peaked there, is another manifestation of what was wrong there. So off air, we talked about how I'm actually controlling the flight simulator via the debugging interface, which is not what it's for. So, speculation time. I think what's happening under the hood is that the debugging interface is periodically grabbing data from the internals of the flight simulator and presenting it to the debugging interface. So I think it's either it's pulling or it's pushing, but I think it's only happening periodically. Certainly I can make as many requests as I like, but the data only gets updated about once a second. But it's inconsistent. It's not once a second. Sometimes it's 1.5 seconds. Sometimes it's 0.8 seconds, and it's all over the place. And I think what's happening is that is in a completely separate thread from where the main simulator is running and all the calculations are being done. So I think there's a race condition sometimes between when the position gets updated, the longitude and latitude don't always get updated together. So you might be moving in a diagonal, but you only receive one of the values, and so it looks like you've moved one side of a square rather than moving the diagonal.
I see.
So that's one of the forms of error that has come in there. So I'm guessing what happened is they introduced threading, and it wasn't thread safe, but hey, it's a debugging interface, it doesn't matter. So that was one form of data corruption that I was getting. There is another form of data corruption that is happening which is larger than that, and I haven't done enough digging to work out what it is, but I ended up making a spreadsheet, and that would actually be really interesting to look at. Now you also notice that it is still in an oscillation and it's not settling out yet. I have had configurations where this has worked well and configurations where it's not working well. It looks like I'm in one of those at the moment. Let's have a quick look at this landing as it happens here. Now you can see we're in an oscillation, so this is not going to be anywhere close to a good landing. It's probably not even going to be anywhere close to my best, but at least we can see some mechanisms happening. For example, the landing gear has just come down, and you can see that the flaps are fully extended now.
I see. I actually have a really important question. Are the passengers safe?
They should be safe.
All right. Then please proceed.
Fantastic. So you can see here earlier on, yes, I began with 300 and something magnitude oscillations, but I then got down to sort of 20 something. And over here, we are now up at 320 here. There was 290 something back there, and these oscillations are quite large again. That just means that I need to do some tuning. We'll talk more about that in just a moment. But what I want you to see here is the touchdown. I only spent a few hours working on the landing, so I haven't fully fine-tuned it. But you'll see the idea basically works. So you're going to see it's going to do a little bit of a flare, and hopefully, I can't remember whether I fixed the overflare problem that I had. So we'll see that in just a second here. It's just about to cut the throttle. I said it's just about to cut the throttle. It has not cut the throttle, and I don't think it's going to at this point.
I sort of see we are making BBC headlines.
Yep. See, the speed is still decreasing, which means that we're probably about to go for a swim. Ah, that's a shame.
I'm so impressed. Actually, you implemented the landing of water as well, which I don't think it's a very simple maneuver, but so great.
Absolutely. Let's have a look at this here. This is a folder I've automated collecting all sorts of stuff. So I've got, let's go into one of them. So in here you can see there are a couple of spreadsheets here. This is a CSV file, which is basically all the black box recording from the flight. This here is when I've actually opened up that data and made any modifications or tried to answer questions, and I've highlighted stuff and everything. That's where that ends up. I've got various Git information, so then I know what code it was that gave me that result. And then history.kml, that is the data which was used to generate the live map. So I've got all of that. And then importantly, this here is a screenshot of what my screen looked like at the time when I did the capture.
Are you able to completely replay the KML file and have both the plane acting in the same way and also the map showing the same position?
I don't have that, but if I go to a more recent one, like for example one of these, and you can see I've got some links to the video capture that I did for that particular flight. So
I hear you, but I know that we don't have video capture for this flight.
Yeah, well, we've got video capture of the desktop that I'm showing you at the moment.
Okay.
So we've at least got that, but we don't have video capture on the actual desktop itself. But you can see on this one here, so here I'm starting up the autopilot, right, okay, we're on the runway and everything. I want to come back to the data problem. I told you before about how sometimes the longitude or the latitude was updated, but they weren't updated together sometimes. I made an algorithm fairly quickly that was very good at detecting that and dealing with it. However, I was still getting some extreme wobbles from time to time. And you can see in this graph here, this is the distance we are from the line. The green represents how far away we actually are from the line. And then the yellow, most of the time, it's underneath the green line. But there are times when it shoots down, and it's shooting down by quite a considerable way. And so my other
Couldn't use, for example, maybe moving average or something to kind of smooth the errors?
The problem was with the moving average was that I had to use a very strong moving average, which meant that I was dampening the signal, but the error was still coming through very strong.
Makes sense.
I spent a day in this particular spreadsheet, prototyping various algorithms. And you can see here, this green line is my prototype algorithm for filtering out that data. So as I went along, I slowly sort of found more and more edge cases for filtering out different points. And you can see here that most of the time it's working excellently. And then every now and then there are a few points that get excluded that shouldn't have done. And you can see there's a batch of them just along here as well. So
so the yellow points are excluded.
Exactly.
Oh,
So
I see.
this flight that this came from did not have the data cleaning on it. So you can actually see the effect of not having clean data there, because you can see these yellow points telling the plane, hey, we're a long way from the line. So then the plane starts jerking. You could see the controls jerking around as it was getting these bad data points. And so then that was causing it to get into these much bigger oscillations. So you can see here, it ended up, it's a bit hard to see, but you can see coming up to the line there, it should have actually been...
Kind of smooth it out.
Yeah, it should have been smoothing out and slowing down, but actually it's getting steeper there. However, once it was getting close, the overshoot algorithm was starting to really kick in, and then on this side the FOMO algorithm was really kicking in because, hey, it's going across the line really quickly, and so then it started to turn, and then it turned very rapidly, and so then the plane had a lot of angular momentum around here, and that's why it shot way off down here. And then all of these also can cause a similar result, which caused it to shoot back very quickly, and then these made it shoot up even more. So there was that. So like I say, I spent a day in the spreadsheet. Actually, let's just give you a quick view of what the spreadsheet looks like.
I mean, I don't see much of it.
That's okay. All I want you to do is just sort of perceive the size of the spreadsheet. I'm not sure.
And
Can you see?
what is this data?
A lot of it is from the flight simulator. Some of it's from the autopilot. But it's basically the state of the autopilot. The rows are samples in time. They're roughly 1 second apart. And these are all the different variables that are in use within the autopilot.
Makes sense.
These ones which have the grey headings, these are the ones that were of particular focus, and you can see these ones here. These are particularly interesting fields, and then the green ones are ones where I have calculated on the spot to figure out that algorithm. And we can actually scroll down and you can see all of this, all of my calculations and everything happening there. And so then I've got some conditional formatting on here to sort of highlight. So this is trigger 2, this is trigger 1. I only had 2 triggers at this stage. I eventually got up to 3. When the right combination of triggers fire, that's when the combined value fires, and then that value gets muted. If we go back and have a look at the autopilot output, you can see here we've got mute equals 0, so it's not muting the data on that one, but you can see mute equals 1 here, so it has actually muted the data for that data point. So at the moment, we've talked about distance from the line, and you can see here are some various graphs, me graphing various things of what's actually going on with the data there. And then this is the graph I was showing you before, which is sort of the final test of the algorithm. And that was all great. I got that implemented and very visibly improved things. However, I still had an issue. I had the distance from the line cleaned up, and I did several more iterations sort of improving that over time. But something else became apparent once I had that fixed, which was that I was still getting really erratic results on the top end of the ice cream. So ignore the fact that the scope is sort of overshooting a little bit here. That's another story for later on, but probably isn't interesting enough for the video. But what was happening is it would come around the corner here. It would be okay, or it would suddenly shoot off on a line going up, or it would just sort of do these really random things. And when I went and looked at the black box to see what was going on, my distance from the line calculations were now working fine, but anything that relied on the heading was doing erratic things when it got to this corner here. And that seemed weird to me because it was always happening in roughly the same spot. And I thought, well, if it's always happening in the same spot, that suggests I must have a bug in my algorithm where it's behaving incorrectly or whatever. And I spent quite a bit of time sort of diving into that, trying to find where the bug was in my code. And then I went and had a look at the heading values that I was getting from the flight simulator, and they were all over the place. They had similar sorts of errors to what I was getting with the location data. And once again, I don't blame the flight simulator. I'm using the debugging interface in a way that it's not intended to be used. It's not meant to be used this way, so it's highly likely that if I was to be using the correct interface, I probably wouldn't be having this problem. But that was really interesting, and so I was at a point at that moment in time where I had invested a huge amount of time and going down another rabbit hole of data cleaning, understanding why the heading's wrong and how I can fix it and everything. I really didn't feel like I could invest more time going down that path.
Why didn't you switch over to the real API, not the debug one?
Same rationale. It was that it's a whole heap more time investment, and I didn't know how much time investment. It's a completely different API. The API that I'm using is a text-based one over TCP, but the API that I would end up switching to is a binary API. So you actually specify what values you're going to send and receive via the API. You specify those values in XML, and you have to go and put those in a particular path which you need root access to do, and then you communicate that information in binary. All stuff that can be done, but there's going to be some overhead in getting it to work and everything. And so if I put more time into this, that is something that I will invest time in, because then I can get low latency data and hopefully cleaner data. Maybe not, but hopefully. And so the thing that I ended up doing was I just excluded the algorithms that relied on the heading. But then they were some of my best algorithms. When they worked really, really well. And so they gave me really stable results, whereas the other algorithms tended to struggle to keep this plane stable. So I really had to battle with them to tune them to get them to work. And then every time that I would update the algorithm to solve a problem, I would then have to go and retune everything. I would, at the minimum, that algorithm, but very likely the surrounding algorithms would need to be attuned as well, because, well, now this one's behaving differently. So if this one causes it to go to the line a bit more aggressively, then maybe the overshoot needs to be strengthened up a little bit. But if I make it too strong, then it's just going to bounce off the line and take a while to settle out. So that was really interesting. Then we start to get into the real crux of it. I ended up doing more cleaning. I think I've got something like 4 layers of data cleaning going on now. It's things like, hey, we think we have stable data now, but we don't absolutely know it. So we wait a couple of iterations of the data. The cleaning algorithm's telling us that it's stable. Cool. We wait a couple of iterations and yep, still saying it's stable. Right. Now we're going to take action. But then that means that the FOMO and the overshoot particularly...
Yeah, because, I mean, that's the problem generally with the moving average. It's actually getting kind of the data, what you have is getting more in the past.
Yeah.
And any kind of things, when you have to wait for more data to coming in, you're kind of getting more into the past. And at the point when you make a decision, you are way over.
Exactly. And to extend that a bit, with the overshoot and the FOMO, those take quite aggressive action when they need to take action. But if they take aggressive action on top of error...
that's even worse.
Yeah, things go very wrong very quickly. So that's why I made it so that those and a few other bits only take action when the data has been stable for a few iterations and we're very confident that it's correct. But then that means that FOMO and overshoot have much less time in the cycle that they can be acting to reduce the oscillation. So it makes FOMO and overshoot less effective. So a way that I could address that is to extend the sides of the ice cream cone so that then I can just relax all of the algorithms and just say, okay, yep, do your thing, but just take your time to do it, and eventually it'll get into a settled state. If I was to invest more time in this project, that is another thing that I would spend time on. So when we look at this, you can see here, each time we see a data point there, that's roughly 1 second apart. And here we've lost 1 second. Here we've lost 1 second. Here we've lost 1 second. That's not too bad. But if we go and have a look over here, and here we've lost something like 6 to 10 seconds. So there's 6 to 10 seconds where the plane is effectively flying blind. When you're trying to smooth out how the plane is flying, that is a long time to be without data.
Why 15 seconds is that's big of a deal? Because, I mean, for example, if you try to drive a car, yes, if you close your eyes for 15 seconds, I almost guaranteed some bad things will happen.
Yep.
But in a plane, if you don't have data for 15 seconds, doesn't seem to be that bad.
Yes. However, if you're trying to stabilize an oscillation, if overshoot ends up applying for, say, 10 seconds when it only needed 2, then the plane's going to be going in a very different direction to what was originally intended there. But there are some ways around that, which I haven't done, but I could do if I was going to do more work on this in the future, which is things like, at the most basic level, I can make the effort decay. If I simply stop the effort, then every time the data gets muted, then the plane's going to jerk around doing fairly erratic movements. But if I make it decay, for short interruptions, it'll be basically not noticeable at all. For longer iterations, it'll just sort of slowly relax, and then when it's got good data again, then it'll start putting effort in again. And that'll be slightly less smooth, but it'll be affected less by these areas of data drought. Something that would be more interesting that would potentially get an even better result is to go, okay, the overshoot is saying, hey, we need to apply this much force, and then also calculate how long we need to be doing that. So then, even if the data gets muted for a little bit of time, we can still go, yeah, it's been this much time, we should be decaying how much overshoot effort we're putting in, and then we'll still put in reasonable values. But that requires more training, it requires more adaptation of the algorithm. And that really leads into that last point that I wanted to make there, which is that I kept on improving the algorithms, and I kept, every time I was improving the algorithms, I had to then go and retune it. And if the tuning is something I can do fairly close to the runway, like fairly close during takeoff or after takeoff, then I can iterate through those quite quickly. But the further through the cycle that the problem is, the longer it takes for me to iterate through doing all the improvements in tuning.
I keep looking at this project as a failure because I haven't achieved the things that I set out to achieve in the beginning. But that's not really a good way of looking at it, because that's not what this channel is about. It's about trying stuff, failing and learning, and then trying it again and then succeeding. Right now, I'm just on the fail stage, but I've learned a whole lot from it. I've learned a whole lot about control logic, what works, what doesn't, and how the tiniest little change in the algorithm can make a huge difference to the performance of the plane. I've learned a whole lot about cleaning your data and the importance of it, and just how much effect that can have on the final outcome. And also how important it is to let the algorithm know how confident you are in the data, because then you can make some really interesting changes to how the algorithm behaves. I've got masses of data about how the plane performed in each flight, with what code and what configuration. So now I can really go back in hindsight and see, well, this idea worked, that idea didn't work. And I can really quantify stuff. I can really dive into the data and go and ask questions. When I learn something new, I can go and apply it back to all these old flights. It's been so cool to go through that data, come up with a hypothesis, and then go and ask the data questions. Sometimes I prove that hypothesis right, and sometimes I prove it wrong. And so then I just come up with the next hypothesis, and I go and learn about that as well. There are no shortage of next steps that I can try, but there is a definite shortage of time in which I can do it in right now. So, hopefully, the future will solve that problem. Part of why I didn't get there this time is that I was trying to do too much. I am one person trying to learn everything from scratch, not just go and look at Wikipedia to see how it works, but actually learn it from scratch. And the work that I'm doing would normally be done by a full-size team that would be iterating over a long period of time. I'm okay with that. Although I wasn't to begin with. I really did have my hopes up that I was going to get this first go, and yeah, in hindsight it's easy to see that I misscoped this. But hey, that's all part of the learning process. And that's exactly what this channel's for. You don't always have that luxury in the work environment, but when you're doing it as a hobby, you can really mess around like this. If you'd like to better understand the nuances of all of this, I really recommend having a look at the 2 chats between me and Csaba. They're long for good reason. I've tried to edit them down to get rid of all of the superfluous stuff, but there is a lot there. In the meantime, it's definitely worth being subscribed, because if I end up doing more with this, I'm very likely to do it in smaller, more manageable bite-sized chunks, which will come in the form of shorter, more concise videos. No. Do not fall. While working on this project, I've developed an even deeper respect for the aviation industry than I already had. I really hope I can do more of this in the future. But now, I need to do this.